All right, so in this video, we're going to look at graphing lines. And in order to graph lines, the easiest way is to look at an equation that's written in slope-intercept form. So a reminder, slope-intercept form is going to be y equals mx plus b, where we have m, in this case, is the slope, and b is the y-intercept. And so looking at the first problem here on the top left, it is already written in y equals mx plus b form. We have a slope equal to 8 over 3, and our y-intercept is what b would be, which is negative 4. Now, so the way we would graph it is we go to negative 4 on the y-axis, and we'd put a dot, and then we would apply our slope. Now, our slope is change in y over our change in x. Since both of these numbers are positive, we start with the y number, we'd go up 8, and then we'd do the bottom number after that, we'd go right 3. So up 8, right 3, and we put a dot there. And so that would be another point that lies on the line. And you would put as many of these lines on the graph as you could fit, and then connect them with a line the best you can. So I try to make a straight line that goes through there, and kind of goes in both directions, and put arrows on it, and we have the graph for our line. And we move over to the one next to it. So we have y equals negative 1/3 x plus 2. So m, or our slope, in this case is negative 1/3. Now, it's going to be easiest to apply that negative sign to the top number. And we have our y-intercept here to be 2. So graphing, start with your known point, start with your y-intercept of 2, and then go apply your slope. So the slope being our rise over run, or our change in y divided by the change in x, means we would go down 1, right 3 from our y-intercept. So we go down 1, right 3, and we put a dot. And then we would do that as many times as we could fit. Now, I can't go down 1 and right 3 more. I don't have any room. But what I can do is I can kind of work my way over this direction to the left. So what you would do would be do the opposite of both things. So instead of down and right, we're going to go up and left. So we're going to go up 1, left 3, and that lets us get one more dot. And then we'll try to connect our dots with a line that passes through all those points. And we'll go forever in both directions. We'll put arrows on it. Now let's go on to the ones beneath it. And so the next line we have is y equals negative 2. And at first, when you look at this, you'll say, well, this doesn't look like slope-intercept form, but in fact, it is written in slope-intercept form, where basically we have 0x minus 2, and our slope in this case is equal to 0. So we'll go to our y-intercept, which is negative 2, and we'll go put a dot at negative 2, and then we'll apply a slope of 0. Well, 0 being a slope, 0 is the same thing as 0 divided by 1, so basically I'm just going straight sideways, 1 unit in either direction, and we have a nice horizontal line here that passes through all of our points. And so that's a horizontal line. I'll make a note of that, horizontal line. And the last equation that we have is x equals 4. Now, that is not in slope-intercept form, because in order to be in slope-intercept form, we have to have a y, we have to have an x, and we have to have a number. Well, there is no y equals. This is a special case here. This is a vertical line. And the way you graph a vertical line is you go to the number that x is equaling. So I go to 4 on my x-axis. And now, vertical lines have... I hit the button again. Now, vertical lines have a slope that is undefined. So undefined slope means it's going to go straight up and straight down. And so I draw a line that has that same x value the entire time. And it points up and down, going through 4. Okay, now that we know how to graph a line written in slope-intercept form, let's talk about parallel and perpendicular lines. Lines that are parallel to one another will have the same slope. And lines that are perpendicular to one another have slopes that are the opposite reciprocals. And that was in an earlier video. So what we're going to do is we want to graph a line in this first one on the top left-hand corner. I'll zoom in. That is parallel to the one that's given. Now I'm going to color code here, and I'm going to graph that line that we want to be parallel to. So that line has a y-intercept of 1. And so that's this number. And then we have our slope of -4. The slope is the number that multiplies to the x. Well, -4, I need to write that as a fraction, would be -4 divided by 1, which means I would go down 4, write 1, and put a dot. And then I would do that as many times as I could fit, and I can't go any farther to the left of that point. I can do a little better than that. So I get my little arrowhead. I can go, instead of going to the right, I'll go to the left. So we'll go up, do the opposite of both. Up 4, left 1, put a dot. And then we'll try to connect those dots. All right, so there's the line that we want to be parallel to. Well, parallel lines have equal slopes. So my new line, the parallel line, is going to have a slope that is the same number. So -4 over 1. And then we're told we want to go through the point 1, 1. So I'm going to put a dot at 1, 1. And then I'm going to go apply my slope, which says go down 4, right 1, and put your dot. And then from that initial point, I could also go up and left and put a dot. And so I have these points here where I can make my lines so I can see the two parallel lines. Now let's do the same thing here. So I have a line that I want to be parallel to. I want to be parallel to the line y equals 4. And we saw a little earlier that if I have y equals a number, that's a horizontal line. Which horizontal lines have a slope of 0. And so it crosses the y-axis at 4. And I'm drawing a line that passes straight through there to make that horizontal line. Now, we want to be parallel to it. So my parallel line is going to have a slope of the same number. They're both going to be the same. And it needs to go through the point -4, -3. So I'm going to go put a dot there. And the only way I can draw a line that is horizontal passing through that point is going to be right here. So a flat line at y equals -3. Now let's do some examples of being perpendicular. So a line that is perpendicular to y equals 2/3 x minus 3. Let's graph that line first, so that way we can see visually. So the y-intercept of that line is -3. We're going to put a dot there. The slope of this line is 2/3. So that means I go up 2, right 3, put a dot. Up 2, right 3, don't have enough room. And so let's go back to our y-intercept. Go down 2, left 3. And so I get a couple of points here to work with. And I'm going to draw a line that goes through all those points. And now we can work on this perpendicular line. So remember that the slope of our line here was 2/3. We need to get the slope of our perpendicular line. The perpendicular line will have a slope that is the opposite, so I change the sign. Reciprocal, flip the number. So change the sign and flip the number that is the original slope. Now that I know the slope, let's take the fact that it passes through the point 2, 2. We'll put a dot at 2, 2. And then we're going to go apply our slope for this line. -3/2, so down 3, right 2. And I don't have room to do that again. So the other option is to go up 3, left 2. So I got a couple of points to use here, and we'll make our line. And one more example of the parallel and perpendicular lines. So now we want to draw a line perpendicular to x equals negative 3. So the graph x equals negative 3 is a vertical line that passes through that point. So I'm going to draw a vertical line that goes through x equals negative 3. And we want to be perpendicular to that. Now, perpendicular to a vertical line is going to be a horizontal. So a horizontal line that passes through negative 3, 4. So I go to negative 3, 4, put me a dot, and I want to be perpendicular to it, so they got to cross at right angles. And I have my perpendicular line. Okay, last part of this video here is we're going to talk about how to graph linear inequalities. So we already know how to graph the equation of just a standard old line. Linear inequalities represent the set of values that can make a true statement. So these could be more than one number. Now, the difference is when we're graphing is we have to pick between, do we want a solid line, a dashed line, and do we want to shade below the line or above the line? If we have an inequality that is less than or greater than, so I have the inequality symbol with no line up under it, you're always going to use a dashed line. So less than or greater than dashed line. If I'm less than or equal to, so I have the line up under the inequality, use a solid line because any number that falls on the line can be used to make that a true statement. So that's how I know if I pick solid or dashed. The way I know if I want to shade below or above is if your inequality is less than. So y is less than or y is less than or equal to, you shade below the line. If y can be greater than or greater than or equal to, you shade on top of the line, you shade above it. And an easy way to tell whether or not if you're shading on the correct side of the line is imagine that the line is a tree. And if this was a leaning tree, below the line would be if where the tree would fall down to. So this tree that is leaning, if I'm standing over here where I'm highlighting on my screen, I am standing beneath the tree where it could possibly fall down. But if I'm over here on this side, that would be above the tree, where if it fell, it would not fall on me. So let's do this first problem. We want to graph the linear inequality y is less than 1/3 x plus 1. And you start by finding the slope, which the slope is 1/3. The y-intercept is 1. So because that is in y equals mx plus b form. So we'll go to 1, put us a dot, as 1 on the y-axis. And then we go apply our slope, up 1, right 3, and put another dot. And I can only get one dot in that direction. So we'll go the other way. We'll do the opposite of both. So we'll go down 1, left 3, and put a dot. Now, we have to figure out what kind of line to use. So we look at our inequality. This is less than, not less than or equal to. So since there's no line up under the inequality, we're going to use a dashed line for our curve. So a dashed line. And now we want to figure out, well, which way do we shade on this? Well, since y is on the small side of the inequality, it's not on the open side, y has to be less than, so we're going to shade underneath the line. So I would shade the graph all up under here. Now we have another one. So in this one, we have y is greater than or equal to x minus 5. And we want to identify the slope, and we want to identify the y-intercept. Well, the slope in this problem is 1, and the y-intercept here is negative 5. So I'll go to negative 5 on the x-axis, and I'll put a dot. Now my slope being 1 means we're going to go up 1, right 1, up 1, right 1. And I'm going to keep doing that until I run out of space. And now we got to figure out solid line or dashed line. Well, this inequality has the line up under it, so that means we can be equal to any number on this line. So I'm going to use a solid line here. And now I also look and see that the open part of the inequality sign is towards the y. That's the big side of the inequality sign, which means that we shade above the line. So any number, any coordinate that lies above the line will make a true statement on the inequality. Two more. Next problem, we have y is greater than 2. So this is our horizontal line, because it's just y equals a number. So we'll go to 2 on the y-axis, and we're going to make a horizontal line. Now the kind of line we're going to make is we look at the inequality. There's no line up under it, so that means use a dashed line. So no coordinate that lies on this line can be used to make a true statement. And now we figure out the direction of shading. Well, the open part of the inequality sign is towards the y, so y has to be bigger, so I shade above the line. Last problem. X is less than or equal to negative 3. So this is a vertical line because it's x and a number. So we'll go to negative 3. We know this line is going to go straight up and down. The inequality sign here has a line up under it, so it's going to be a solid line. So I'll make my solid line here. Now I got to figure out the direction of shading. Well, the pointed part of the inequality is towards the x. So that means x has to be smaller than the negative 3. So smaller means we're going to shade to the left.